Hello and welcome to today's ChannelCast. Get the inside edge on the HE500 series, sponsored by the Channel Company and Scale Computing. My name is Ed Hannon, and I'm excited to be moderating today's ChannelCast. First, to ensure you and the audience get the most from today's event, I have a few announcements and suggestions for you. At any time, you're free to ask questions of our presenters. You can submit your questions by typing them in the Q&A box in the top right-hand corner of the console. The presenters will advance the slides for you automatically, so you don't have to do anything except listen and take in the presentation. And you can also download a copy of the slides by clicking on the Downloads button, also located in the top right-hand corner of the console. And finally, if you have any technical problems, let us know by clicking on the Help button, also located in the top right-hand corner of the console. Joining me today is Scott Mann, Director of North America Channel with Scale Computing. And before I turn it over to Scott to talk about what he's going to cover, I'm going to talk for a few minutes about some of the technology and where today's, the HE500 series sort of just set the table for where that's going to fit, in the marketplace and, with your current technology platform and sort of, offerings. So the first thing that I want to talk about is this notion of, edge computing, and because that's one of the things that Scott's really going to cover in a little bit more detail. But when we talk about edge computing, we're talking about that mix of compute and storage. But where sort of the edge of that market, where that sort of market, sort of runs out, is kind of hard to define. And you can see here just some of the numbers from the different sort of industry watchers. And, they put these together every year in terms of reviews and previews and projections and forecasts for, where these things are sort of, where they are and where they're going. And they do it for all the different technologies. And they really slice and dice this stuff up, regionally, globally, by verticals. You can kind of pull the numbers from wherever you want and how deep you want to dive into it. But just for sort of overview look, you can see here the edge computing market is projected for a 41% compound annual growth rate, from now through 2023. And we did one of these, I think, last year on edge computing, and the numbers weren't as strong. And you can see the sort of the ramp up is heading in that upward, the tail is heading up, which is what you want. And you can see also, Grandview Research says that the global edge computing market will reach almost $29 billion by 2025, which is a 54% compound annual growth rate. And what's pushing sort of the edge to, what's sort of, driving that edge forward is things like the growing limitations of front-end devices, 5G, Industry 4.0, decentralized computing to lower the latency, and, making sure that network traffic is optimized for sustainable energy. So these forward-thinking, technologies are really moving all this stuff forward. And how edge computing sort of manifests itself in the actual applications, other than the technologies, are things like IoT, RMM, again 5G, AI, driverless cars, and fleet management. And when we talk about the edge, the question then turns around to, who's the sort of the leader in this, and who's sort of pushing this stuff forward? Well, there are vendors out there, including, our friends from Scale, that offer things like ease of use and high availability and lower TCO and, stronger uptime and easier deployment and management. And, when we talk about the HE500 solution for Scale Computing, which Scott's going to do more in a few minutes, I want to talk about, before we get there, sort of the power of a strong partner program. And, when you're looking at the vendors that are covering this technology and sort of offering this technology up with their solutions, the solutions are the solutions, but the partner program can sometimes be the difference maker. When we're talking about partner programs, look at the one that you're working with now. Do they offer things like making you the primary contact for prospects and existing end user customers, and also being the liaison between the vendor and the customer? And also, does the partner program support two-level distribution worldwide, where the distributor supports the partners and also simplifies the transaction process? So again, when you're reviewing either the vendor you're working with or the one you want to work with, keep these things in mind. And before we go any further and talk more about partner programs, it's probably best at this point to tag Scott in. And with that, Scott, I'm going to hand it over to you. Take it away.
Thanks, Ed. Fantastic summary. So welcome all. I appreciate everybody taking the time to join us here today. We're going to be talking about the HE500 series, as Ed had mentioned, and more importantly, we're going to be talking about edge computing, where this all really came from, and what's leading up us into this new series, driving down the footprint of the size of the series, the capacity of the series that we have. So just to quickly get into the agenda here, let's jump right into this. What we're going to be talking about is that getting in a little bit more detail on that industry trend of edge computing and the drivers behind it, and understanding what the main driver to edge computing is, and then what industries edge computing is affecting, and then why scale is such a good fit in this edge computing space, and what the trend with from the infrastructure side is moving towards, with driving smaller and smaller form factor systems, which has led us to come out with the HE500. And then some of the benefits, we're going to dive really deep into the HE500, talk about the product family as a whole, what kind of capacity you can get to, and the benefits of this system in comparison to some of the other families we have, like the 1000 and the 5000 systems, and then ideal use cases for it. So the main thing to hit on here is that edge computing itself being a new trend in the industry, and it is the driver for this HE500 series. It's not limited to edge computing. The advantage and what we're seeing in the industry is really that the SMB and the MSPs are really benefiting from all of these trends in edge computing, because what's happening is the footprint of the systems that companies like us are coming out with are getting smaller and smaller, and it's not only benefiting these edge use cases, which we'll touch on, it's also benefiting the traditional SMB customer and the MSP that would sometimes never even consider hyperconvergence, or hyperconvergence may have been too expensive for them at any point in time before, because now we're coming out with a hyperconverged system that applies to these edge use cases, which is smaller footprints, and that's exactly what an SMB customer is, the exact needs of an SMB customer, as well as MSPs that have even smaller SMB customers. So first, let's touch into edge computing, why edge computing, and what's really driving it. And that's the common term that everybody has probably heard it many times before, IoT, the Internet of Things. And really what the Internet of Things is a bunch of sensors and data collectors that exist outside of the four walls of the traditional data center. So they exist at the remote locations where the traditional data center we've built all these best practices around doesn't exist. So think in a gas station scenario, it's at the physical gas stations that you drive into. In a retail scenario, it's at the grocery store that you're walking into. It's not at the head office. It's where they're leveraging all new technology that is allowing them to make their organizations more efficient and more productive, and competing against the likes of online competition. And it's driving a need for compute resources at these edge sites. So it's really, the edge computing is the compute that exists outside of the four walls of the traditional data center. And this is kind of further into some of the numbers that you saw from Ed with the compound annual growth rate and everything, but what does the trends look like? What are the analysts saying around all these trends in the industry? And the first one at the top there, like the 2010s were the decade of cloud computing, and the 2020s will be the decade of micro data centers at the edge. So this is where we're talking, this is the edge computing use case. We're looking for micro data centers, higher compute data centers at a smaller form factor that can live in a grocery store, at a gas station, where they might not have these ideal data center conditions. And the driver behind that, why that trend is happening, is because currently and today, around 10% of enterprise generated data is created and processed outside of the data center. So it's 10% of it is processed at those edge sites. By 2022, Gartner predicts that the figure is going to reach 75%. So all of a sudden, we're having this boom in digital information that's being collected outside of the four walls of the data center, which still needs to be regulated. It's intellectual property that still needs that needs to be secured, and it's very important information for a company to be able to leverage to push out processes company-wide. So now we're collecting all this new data, and that's the reason why we need these micro data centers, because we need to have all of the same benefits that we get from a traditional virtual infrastructure with all the backup and redundancy and security that we've built into it, but we need to have it at these sites that don't have the four walls of a data center. They don't have the security of a data center when you're walking in there, and the ideal weather conditions of a data center. And I think Ed's numbers actually look even more appealing than this, but today we're looking at a $10.6 billion opportunity. This is going to grow to $21 billion by 2023. And that compound annual growth rate that you see from Ed is probably more of a current prediction because these numbers are from the start of the year, but it's a 14% annual growth rate. I think Ed was looking at 54%. So you can see there's a huge opportunity here. And the reason that this growth rate is continuing to grow is because there's new applications and new industries that are starting to adopt the use of IoT to build out better new practices and to build out more efficient and productive environments to make them more competitive and to increase their bottom line. And really, if you think of what edge computing is the reason they call it the edge. It's a high performance bridge between those sensors, those things that are at the edge, and their private and public cloud and the four walls of that data center. So in all the different use cases, there's many different scenarios. What I always relate back to as a personal use case would be if you had a Tesla smart car, and that smart car has connectivity to the cloud, but it's got all these sensors around it, right? It's analyzing the entire environment down. If you're driving down the highway and you come up to an 18-wheeler that is that you're about to T-bone, you want to make sure that car has the capabilities to act on its own and to react to everything, all the sensors and the information that it's gathering, and stop, as opposed to sending that up to the cloud where you're going to have some sort of a latency in comparison to what you can do locally. So that car that will stop on its own, and you won't end up running into that truck. If you think of these different use cases across organizations, they're running with the same scenarios. In retail, they want to be able to assess any information of us walking in there and being able to provide us with a new customer experience so that they can help upsell, they can help cross-sell, and they can give us an experience that you wouldn't be able to get from online shopping. Within healthcare, we have a lot of new systems that are leveraging technology, and healthcare is going from centralized to decentralized, where you're getting more of a local community healthcare, and those are going to still need to have the latency in any of their systems that they're running, and then having to send everything back with it to a head office, we can run into bandwidth issues. You got in the banking scenario, you've got everyone's going tellerless in this modern era. You see everything from financial institutions to banking institutions. They're creating an automated experience when you walk in there because they need to adjust the experience that they have to make it convenient for you to be able to even want to go in to the banks and to these financial institutions because online banking and online finances are becoming a lot more convenient, so they need to be competitive from that scenario. Then you've got the smart cities, being able to leverage all the smart devices across the city from videos and such. Transportation, shipping. You're talking about trucking, being able to send a truck without anybody in it from the west coast to the east coast, being able to monitor it all along the way. You know, have that truck collect all the data that it needs to collect and send that back to the head office. It's doing all these things that it needs to have these local compute resources. In the retail scenario, we don't just have regular freezers now. We got freezers with technology in it. We don't just have paper digital signage. We don't just have paper signage. We have digital signage that's creating a custom experience for us as the user. We take something off the shelf, that environment already knows that we've taken it off the shelf, and it's able to charge us when we walk out of the store. It's also able to tell the inventory that we're going to need X amount of inventory, so we can be more accurate with the forecast of the products that they actually purchase. Now, all that information that's being collected locally and gathered, it's going to be processed locally, and then it's going to be sent back to the cloud for all that AI and machine learning that's happening. And then those processes, based on the data and everything that they're gathering, can be pushed out organization-wide. So they're still benefiting from the use of the whatever environment they have, whether it's a private or a public cloud, and they're still able to send all that information back and maintain that information from an archival perspective at their head office or whatever that private and public cloud is, but they're able to adapt more quickly to any changes that they need at those local sites. So when you think edge, what does the edge sites really require? And you think in most of these scenarios, you're not going to have sometimes maybe one person in IT. A lot of the times there's going to be nobody that manages the IT. Think of a gas station. A gas station is just going to have that clerk there, and you're going to need to have all that IoT built into these super gas stations that we're seeing that provide a great experience. So it's going to require these edge sites that have no staff. It's going to require substantial ease of use, not only on the installation side of it, but on the day-to-day. The system needs to run itself. And it needs to run itself, and they need to be able to manage this all remotely. And they need to have the automation that's built into it so that that system can run itself and stay up. And if something does happen, like a drive failure or a node failure, that system can withstand that type of a failure, and it can continue to run without having somebody local be able to jump to it and get on site to fix whatever problem happened, because every single minute of downtime is just dollars that are being wasted, dollars that are costing that organization. And now we're talking thousands of sites. That becomes a lot of dollars over a lot of different hours that could be down. And the sites need to deploy very quickly. In today's environment with technology, we have changes that are happening, and if those changes take us 5 years to deploy, we're already going to be behind the 8 ball with our competition. The competition's already going to be ahead of us and implementing new technologies. So we need to be able to deploy these quickly and at a minimal cost. It's something that they can create kind of an as-a-service model so that they can put together all the applications and everything they need, put it on this bundled micro data center in a box, ship that to whichever sites they need to be shipped to, and not have to send their tier 3 support over to those sites to do the installations. It could be something that they do use any local resources to do that installation, because it's a very simple system to deploy. Now let's look at the actual edge site multiplier. So now we're talking not just a single site now. Now we're talking tens to hundreds to thousands of sites. So the cost and the resources and the time that takes to do these implementations, you got to think about it not just that one single site, multiply that by the number of sites and the amount of time and resources that they're wasting by having a solution that doesn't answer those requirements that we just talked about. So if you look at, let's take 240 sites as an example, an extra 10 minutes of management of time for each one of those sites adds up to be a 40-hour work week, adds up to another individual that they need to just manage those sites. And an extra 4 hours of deployment time per site. So we're talking about how quickly we get this all deployed to get the new technology out there, times those 240 sites, that's an extra 6 months of added deployment. Now let's talk about thousands of sites. Think about how many additional months it's going to take to deploy those, and how quickly technology changes. That comes 6 months down the road, are we going to need to add new technology that we're already behind the competition? And then an extra 24 gigs of RAM of resources, that the overhead that that platform is consuming, times those 240 sites, that's about 5.7 terabytes of resources overhead, a resource overhead across those sites. So even a small amount of resources across all of these sites adds up to be a large cost that's added to the bottom line. And then an outage at any single of those sites, it can cost thousands in lost business, thousands more in dispatching IT resources. If you're thinking of having to send local resources, having to pay them top dollar to send those resources on site to fix any of those things. That's why it's so critical to have a system that can maintain those self-healing, so we don't have to send somebody on a Saturday where it's going to cost us 2x to be able to send them on that Saturday. We can wait till Monday when it's irregular hours, because the system is still running, that they're still able to have all their applications up and running and collect whatever dollars they're collecting on the day-to-day. Where did scale come from, and what makes scale such a great solution for this edge computing? And I'm not going to hit on all of these different slides here. Just really want to help you understand where we came from originally and how that set the foundation and helped us segue into this new trend in the industry, why we did such a great foreshadowing of why this kind of foreshadowed to where we're at today. So in 2012 was when we launched our hyperconverged solution. And for those that aren't familiar with hyperconvergence, taking servers, storage, virtualization, putting it into one single platform. So taking those 3 layers that would typically be separate management layers and putting that into one single management layer where it could be managed by a smaller IT department. Virtualization at that time wasn't built for the SMB. Traditional virtualization, it was never built for these smaller SMB sites, small to mid-market size customers, I should say, that have 1 to 5 folks in IT, where they typically have to be the IT generalist. So what hyperconvergence enabled them to do is be able to manage, not have to reactively manage this infrastructure, have a system that they can put in, set it and forget it. And when we launched this hyperconverged solution, HC3, we started out at the foundation. So we didn't add another layer on top to make it, add more overhead to it. We started at the foundation of the actual architecture to make it hyper efficient. And this is with the purpose of being able to future-proof our solution that we have here today. And the irony of that is we gained a lot of traction in the small, medium-sized market. We created a system that these smaller sites with minimal amount of IT experience, or not IT experience, a minimal amount of IT employees at those sites, they could manage and go work on the other projects that build up on their plate. Now, come 2017, we've become the leaders in this small to medium sized market for hyperconvergence, and something kind of magical happened. This foundation that we created and this solution that we created had a new need in the industry because of this trend of edge computing. And we ended up getting pulled into these retail spaces, into these distributed enterprises. And we ended up winning the largest HC3, one of, if not the largest HC3 deployment in a retail, the top 3 retailer in the world, which has thousands of sites, over 10,000 franchises. And it's because they're building that future-ready store, that future-ready store infrastructure that they needed to deploy. So they're creating what's called a store as a service, so they can go deploy it, exactly what we're talking about. And then in 2018, we launched our HC3 Edge platform. So we productized all that. We built features to make it that we can manage these sites from the other side of the world, that we can manage thousands of sites from a single console. We productized all that and made it ready within our HC3 Edge platform, which is available to all of our customers, all of our partners that we have today. And now 2019 rolls around, and we now are launching our first actual product that is built specifically for the edge computing use cases. So the HE500 series that was built in mind with the edge computing in mind, some of these smaller deployments, form factor systems in mind. Now, from an architectural perspective, what makes us really different, for those that are familiar with hyperconvergence, on the left side there, we've got a traditional hyperconverged model. That's called the VSA model. So VSA model is a virtual storage appliance. So it's basically taking a physical SAN and virtualizing that. Now, there's a lot of overhead resources associated with that. So if you have a physical SAN and you're virtualizing it, those resources that are in that physical SAN still exist. It just exists at the virtual level. So we're taking, within that model, you're taking around 72 to 300 gigs of RAM and 12 cores. And if you look at that spaghetti diagram on the left side there, that's the data path that any block change has to go through. So if you have Microsoft Word installed on-prem and someone makes a change from a period to a comma and click save, that's the data path that has to go through in order for it to write it to disk on the node that it lives on, and also to write it redundantly to the second node. So it's about 4 times the amount of data path that Scale's HC3 or hypercore system would run. So on the right side there, that's HC3. We've got a much more efficient architecture. As I mentioned, we redefined the foundation of what the virtual architecture actually looked like. So now from that perspective, it takes 25% of the time. So if you think about putting 2 of the exact same cars on a road, on the left side, that car has to go 4 miles. On the right side, that car has to go 1 mile. You have the exact same driver in the seat. You have the exact same engine under the hood. Which one's going to get there fastest? Obviously, going to be the one that only has to go 1 mile. There's nothing else that you can change about the variables. So from that perspective, we created a system that's higher performance, and the OS consumption on that, we're consuming a fraction of what the VSA model would be consuming. So it's consuming around 12 gigs, max, I should say, 12 gigs of RAM and a fraction of a core across a 3-node system. Now, if that's a 1-node system, that's 4 gigs of RAM and a fraction of a core. So that's where we can run in these perfect SMB environments, but it's also great for these new use cases where we're getting smaller and smaller with these form factor systems, where we don't need, it's not a company that has a terabyte of RAM where 72 gigs of RAM being consumed isn't going to make a big hit. It's companies that might not even have 100 gigs of RAM, where 72 gigs of RAM is going to consume a lot of it. So let's look at some of the different platforms that we're going to see in these scenarios. You're going to see something like a 64 gig of RAM, and starting out a VSA model on the left side there, that VSA model is going to consume a pretty good chunk of it without turning on any other features. You add more to it, it's going to consume more and more of those resources. On the right side with HC3, we can still run a substantial amount of workloads on that, consuming 60 gigs of available resources left to run. But in the edge space, these aren't usually the typical 64 gig RAM nodes. They're typically even smaller than that, especially if we want to factor in redundancy from a cost standpoint. We're looking at 32 gigs of RAM. On the left side there, you don't really have any space to run VMs. On the right side, we still have a ton of resources available. They can still run those 4 to 6 VMs that they would typically be running. So this foundation that we created is what led us into creating HC3 Edge. Introducing HC3 Edge, where you've got the IoT, and then where Scale fits is that edge or the fog, which is more like a micro data center. Edge is more like a nano data center, and then the core of the cloud. We can connect into any existing data center that they already have. For if it's a larger enterprise organization, we can also run we can also be running that private cloud with leveraging HC3 as well. Our largest customer is about 1.5 petabytes of storage. Our smaller customer is probably under terabyte of storage. So the amount of capacity definitely depends on the use case and the customer that's going to be implementing the solution. And you can tell with what I'm showing here in the graphic where we're going with that size of the footprint. So now we're introducing our HE500 system. We're getting a smaller form factor. We're going to be continually decreasing the size of those systems that are available for these use cases that require it. Now let's dive into the HE500 series. So the HE500 series, it is a fully functional platform that we have. It has no limitation on any of the features. It's not that it's a scale down of the features for less of a light version of it or anything, and it's fully compatible with all of our other systems, our HE1000 and our HC500. A customer that has 1.5 petabytes is running an HC5000 system. They wanted to add HE500 series to their system, they absolutely could. The more likely they're going to deploy an HE500 single node or cluster at a secondary site. Or if you have a customer that's running HE500 systems and they maybe outgrow those and they want to add something with a larger amount of capacity into them, they can add on HE1000 and HE5000 to that as well. So it's the exact same operating system that we're running under the hood, all the same functionality. It's just a smaller form factor, so it's micro data center ready. Now let's look into the actual resources that we have with these. So these are the different product lines or the different products within the family. There's the HE500, the 550, the 550F, the 500T, and the 550TF. Now anything that ends in a T, you might have guessed from the previous slide there, anything that ends with a T is a tower node. So those two at the bottom there, the HE500T and the 550TF, those are going to be our tower nodes, which are great use cases for backup, a backup target for them, backup and recovery target for them, or for a single site like a dental office that doesn't need to have that doesn't have a rack capable environment, a gas station where the clerk is going to be running something under the desk and they don't have an ideal data center that they have in there. So those 500 systems, they can go from 4 to 8 drives. They can be all spinning. They could be all flash. And they start out at $5,500. Probably should have hit on that earlier. The starting price point for the HE500 system, a hyper-converged platform, is $5,500 MSRP. And then on the HE500, 550, and 550F, those ones are all rack mount servers. So those are 1U servers. They all have the same CPU capabilities in there, and those CPU capabilities will probably end up evolving along with Intel's capabilities, and then the amount of RAM that is allowed within those processors being 32 or 64 gigs. And then each of them has a different storage capability. So the 500, that's an all spinning. The 550, that is going to be a hybrid node. And then we have the 550F, that's going to be an all flash. So we have all these different capabilities from an all spinning to an all flash to a hybrid, where we can get the performance and the capacity that we need. There's a 1 gig or 10 gig, there's a 10 gig copper, 10 gig SFP plus, and with the towers, they're all 1 gig. The towers are going to typically run as, towers are pretty much always going to run as a single standalone, whereas from the rack mount servers, they're probably going to run as a cluster majority of the time, or most often in these scenarios. So we want to have the performance of a 10 gig copper or 10 gig SFP plus. Now those start out at $5,500. They can expand out pretty widely. The tower server can go up to 64 terabytes in a single node with eight drives running 8 terabyte drives. So they can get pretty beefy, and it's great from an archival perspective if we're talking about leveraging this for a target. And on that note, let's talk about some of the different use cases. So these are the 3 use cases that I see some deployments that will happen in this. Where I mentioned it's not specific to the edge. HE500 we're benefiting from the SMB and those MSPs are going to benefit from all these different use cases. So we're going to have the small to medium businesses where they're going to be running a 3-node cluster. That 3-node cluster is starting at $16,500. MSRP to the customer with your margin built into that as well, and a very healthy amount of margin that's built into that. They can have a single node for the offsite DR, which starts out at $5,500 as well, can span up to that 64 terabyte capacity. So you can have a cluster on the left side there with small to medium businesses, a cluster of, it could be an HE500, it could be a 1,000, it could be a 5,000 cluster, and that replication target, that can be a rack server, that can be one of our tower servers, it could also be any of the 5,000. So you can mix and match these in the environment. Think of it like a Swiss Army knife. Depending on what the requirements are, we can mix and match the nodes in the environment to make sure that we meet the amount of storage, RAM, CPU, IOPS that are required in that environment. And then from a distributed enterprise side, when we're talking in the middle section here, we're talking tens to hundreds, thousands of sites. Each site is going to have different requirements depending on the size of the location. Sometimes it might be standard across all sites, but typically you're going to have a variation in the sizing. So same scenario, you can have the central cluster being in the HE5000 running a petabyte and a half of storage. And then each one of the sites will have different requirements. Maybe some of them are currently running mission critical applications, so you need to get a 3-node HE500 system out there. Some of the other smaller sites, we just want to start them out at a single node because we haven't upgraded them yet to that technology. So we put a single HE500 system in there, and we can add 2 more systems on later on to make that redundant once we put those mission critical applications in there. And then some of those scenarios where we can't get a rack set up, we can put in those tower servers as well. Or that could just be for backup of some of the sites, and everything can replicate back and forth between each other. So I show the arrows all pointing into the central cluster, but they can really create a web of scale. They can create a web of redundancy, geographical redundancy across all these different sites, having them replicate to whichever target you want them to replicate to. And then there's MSP deployments. Those are the under 100 seat deployments that we typically see. So those are going to be your law firms. Those are going to be your dental offices. And in a lot of these scenarios, they still need to have something on-prem. Maybe the on-prem footprint is downsized a little bit. Typically what we'll see is a single server. That single server is going to have a backup appliance that's replicating to the cloud. You can do that all under your umbrella now. You can have a single node on site. It's got the built-in backup and replication. You can do the local file recovery, local VM recovery, and have that replicate all off-site. It can be replicated to a central hosted cluster. It can be replicated to a single node or a cluster that is being hosted at a colo. Or if you don't want to do anything under that, you don't want to have anything hosted, you don't have to worry about the hardware, you can also leverage Google, our Google Enterprise Cloud platform called HC3 Cloud Unity, and you can have that node replicate to Google and have everything running up in Google. You don't have to be a Google CSP to be able to manage that. You just need to order X amount of resources from us, and you think of us as the CSP for Google. We'll have everything set up. You'll be able to set up your customer. We'll give you the IP address. They can now replicate everything up to the cloud. And when you're leveraging Google, the benefit, 3 clicks and they're up and running, and it looks like it's running on its local LAN. So you don't need to set up any DNS changeover or anything like that. The gateway is already established. We can get everything up and running in Google in 3 clicks. So if you have a full site outage, nothing happens to the business. They're still running. As long as the business still has some sort of connectivity, they can get to the cloud, we can still have them running. And with that said, that's everything for my portion of the presentation. Any questions, feel free to reach out. Channel@scalecomputing.com is probably the best alias to get a hold of us. If you have any questions about partnering with us, any questions about the platform, you want to get a price comparison, we can get all of that ready for you.
God, thank you so much. I want to jump in real quick here with a couple of questions that I had for you, which is, first one would be, can the HE500 series be mixed with other larger capacity units?
Yeah, absolutely. So if you're mix and matching any of the different nodes, you want to take into consideration redundancy. So if you have the 3 HE500 systems to start with, you don't want to add an HE5000 system that is the same capacity as the other 3. But with that said, you'd add them redundantly, maybe add 2 of the larger ones to make sure that they can still function if you have a node failure. The rest of the nodes, you always want to make sure we're N+1 redundant. But all the families across the board, not only the ones that are out today, if it's systems running Cascade or the Pearly processors today, we have something that comes out in 3 years, we can mix and match all our families. We have customers that are running 3-year-old hardware. They can implement these new HE500 systems. It doesn't have to be the same chassis. They can mix and match, whether it be an older Dell, Supermicro, Lenovo chassis, whatever it be, you can mix and match them all across the board.
Excellent. And then the other question I have for you is, how would I or someone listening to the program today sign up as a partner?
Yeah, great question. So signing up with Scale is very simple. There's not a ton of, you don't have to go through, jump through a bunch of hoops to get certifications and such. You just need to get yourself, you can register on our site, scalecomputing.com. You want to partner with us, there's a partner section, and that'll fill out the information to get you over to our the regional team, or send an email to channel@scalecomputing.com, and we'd be happy to get you set up with the regional team. The actual process to sign up is very straightforward. It's a contract that's sent over that you click accept on. And really what we're looking for are partners, strategic partners in a specific area where we can service a specific benefit to those partners. We're not an over-distributed solution, so we can provide some sort of a value and differentiation from your competition. And we're looking for partners that we can grow with. So if you're one of those partners, please send us an email, channel@scalecomputing.com. Very simple to sign up with us. We just want to make sure that we have those partners that have the same interest in mind as us.
Awesome. Thank you so much, Scott. And I just want to let everybody know before we say goodbye today that this ChannelCast and its content are copyright 2019 by the Channel Company LLC or its affiliates. All rights are reserved and all trademarks are the property of their respective owners. Any rebroadcast or redistribution of this ChannelCast or any portion thereof without the prior written consent of the Channel Company LLC is prohibited. And I personally want to thank you all for attending today's ChannelCast, brought to you by the Channel Company and Scale Computing. And also, on behalf of our guest, Scott Mann, and our virtual production team, thank you all for your time, and enjoy the rest of your day.